In this video, we talk about smooth maps between two surfaces. Before that, we recollect the definitions from the last video on surfaces. How to define a surface? What is a surface? We have a set S. Here in the picture you can see. For every point in S, if we can map the neighborhood containing the point P to the open set in R2, then we can call the set as a surface, or the neighborhood as a surface. To do that, we need a neighborhood around that point. We don't know the concept of distance on the set given to us. So what should we do to find out the neighborhood of the point chosen on the set? For that, we choose an open set in R3, and we know the definition of neighborhood in R3. Then we intersect this open set with the set given to us. Then we get the neighborhood around that point chosen in the set S. Then if we can map this to an open set in R2, that intersection of the open set with the set S, and the choosing the neighborhood around the point P, if we can map this to an open set in R2, then we can call this surface S as the set S as a surface. So this map must be homeomorphism. It means the map should be continuous and bijective, and its inverse should be continuous also. Then we call that map as a homeomorphism. If the map from the intersection of the subset with an open set in R3 maps to a open set in R2, if this map is homeomorphism, then we can call that set S as a surface. If this map is differentiable, and the map between tangent vectors in an open set in R2 and the tangent vectors on the surface is 1:1, then we can call this surface as a regular surface. So sigma, the map, should be differentiable, and the tangent vectors in R2 in the set open set U should be 1:1 map to tangent vectors in V intersection S. Then we call that surface as a regular surface. So after all these things, now we can define what is a smooth map between surfaces. Before that, let's define, first we need to find what is a differentiable function on the surface. So a function defined on a surface is said to be differentiable if the function defined in the if we can map that function to an open set in R2, if it is differentiable in that set, open set U in R2, that function is differentiable, then we can call that the function on the surface is also differentiable. And this differentiability can also be extended between two surfaces. So from here you can see there is a surface S1 and there is a surface S2, and the phi is the map connecting S1 and S2. So this map we can say it is differentiable when the surface maps to the open set in R2, and the S1 maps to U1, S2 maps to U2 and another open set in R2. So the map existing between these U1 and U2 is given here. We know this is a set in R2. We know what is differentiability in R2. So if there exists a differentiability in R2 for this function, then we can say the map between the two surfaces is also differentiable. If it is differentiable to all orders, then we call this map is a smooth map between the two surfaces. And if it inverse is also smooth, then we call this phi is diffeomorphism. Thank you.